Okay, so number
41.
okay, so you want to read me the polynomial?
X to the fourth plus 6x to the third minus 7x minus 3.
Okay, and we want to know inside the complex numbers, what's the sum of all the roots and what's the product of all the roots? Okay, so how many of you have taught the quadratic formula or something like it? Okay, now, if you have to get all the roots of this quadratic, again, I mean, I could answer the specific question, but the point is, this question is part of a bigger scheme of which I think you'll certainly understand. When you look at a quadratic like that, a monoquadratic, you may need to go to complex numbers to get all the roots. And that's why in 41 I'm talking about it. You might need to go to complex numbers to get all the roots because all the roots of a polynomial live in a complex number. So if you look at x squared plus ax plus b, can you tell me what the product of the roots are? And can you tell me what the sum of the roots are? So for this polynomial, do you know what the sum of the roots are and do you know what the product of the roots are? And I'm taking that people think the answer is no? I mean, can you figure out what the sum of the roots are and what the product of the roots are in terms of A and B?
If it's factorable, then the product has to be B.
Well, the point is, in the complex numbers, it factors. Because, I mean, and that's why in this problem we're saying, if you go to complex numbers, all the roots are living there. So this, in the complex numbers, is x minus the first root times x minus the second root. So this is x squared minus r1 plus r2x plus r1, r2. So, if you have a quadratic, if you go to the complex numbers, and if you go to the complex numbers, you're guaranteed that that's where the roots are. B is the product of the roots, and A is the negative of the sum of the roots. Does that look familiar to you, Algebra 2 teachers? So, and again, it's important that it be monic. So if I had something like x squared plus 7x plus 11, the product of the roots would be what? The product of the roots is 11, and the sum of the roots is -7. Everyone okay with that? Is this something new, or is this just something that you kind of hadn't looked at this way? Okay. So the point is, if you have a quadratic that's monic, you factor it as x minus the first root, x minus the second root, and you can see that the constant term is the product of the roots, and the coefficient of x is the negative of the sum of the roots. So if you write down a monic quadratic, you immediately know what the sum of the roots are and what the product of the roots are. So far, so good? Yeah. So that's for monic quadratics. What about cubics? So if I have x cubed plus ax squared plus bx plus c, so assume I know a, b, and c, can I look at that and immediately tell you what the product of the roots are and what the sum of the roots are? Well, if I go to the complex numbers, again, remember things factor, since this is monic, into a bunch of monics. In the complex numbers, everything factors into linears. So this factors into x minus the first root, x minus the second root, x minus the third root. We may or may not have particularly efficient ways of finding out what the roots are, but they exist in the complex numbers. So, my monic quadratic factors into x minus the first root, x minus the second root, x minus the third root. Now, here are the terms that are easy to get. So we got the x cubed term. Well, I'll write down all the terms. The coefficient of x cubed is easy. What's the coefficient of x cubed? 1. What's the constant term? So, the coefficient of x is very easy to get. The constant term is very easy to get. In other words, how does c compare to the product of the roots? So, how does the constant term c compare to the product of the roots? It's the negative of the product of the roots. So if you had x cubed plus 9x squared plus 43x plus 19, what would the product of the roots have to be? Negative 19. So even if you had no idea what the three roots were, you know that the product of the three roots has to be negative 19. And again, since I multiplied two negatives here, the constant term is plus the product of the roots. Since I multiplied three negatives here, here the constant term was negative the product of the roots. So hopefully what you can see is if you start with a monic polynomial, the constant term is either going to be the product of the roots or negative the product of the roots, depending upon whether you're even degree or odd degree. Does that make sense? Now, the other term that's easy to get, well, they're all fairly easy to get, but if you're ranking them in terms of easy to get, the easiest thing to get is the x cubed term. The second easiest to get is the constant term. Between the x squared and the x term, which one is the easier one? The x squared term, because you'll have, because again, what you're doing is the distributive law says when you multiply this out, you take one thing from here, times one thing from here, times one thing from there. Right? That's what the distributive law says. And you take all 8 combinations of one of the two things from here, times one of the two things from here, times one of the two things from here. And since you're choosing out of different combinations, that's why the binomial coefficients are something, choose something. That all kind of blend nicely together. So, if it's x squared, what I'm doing is, of the three things, in two of them, I'm choosing x twice. So, I can get negative r1 times 2x's, or I can get negative r2 times 2x's, or I can get negative r3 times 2x's. So when I factor out the x squared, it's x squared times what? Well, it's x squared times negative r1 plus negative r2 plus negative r3. So the coefficient of x squared is the negative of r1 plus r2 plus r3. Can you see how you got that from the distributive law? Okay. So, in which case, how does a compare to the sum of the roots? A is the negative of the sum of the roots. So for this thing, the sum of the roots would be negative 9. So hopefully we're beginning to see